Hi there, welcome back to Career Launcher YouTube. In this particular video, I'm going to take you through one set of games and tournaments, though it will not seem to be a set of games and tournaments. But what I'm going to take you through essentially is how do you do data representation and how do you actually form a points table if required. How do you form a matrix where who won and who lost if required in games and tournaments? And using that itself, I'm going to answer a question of CAT 2021 slot 1. So without much ado, let us get directly into that. So yeah, so let's get started. So data representation points table, the points table in games and tournaments is what I have put on the right hand side, but on the left hand side what I have is generally how do I represent data in terms of uh, the pointers that are given, data points that are given. So let us say that there are 4 teams in a tournament who have to play one match each against each other. So 4 teams A, B, C and D play one match against each other. One match against each other. Now let us say A won all the 3 matches. A won 3 matches, B won 2 matches, C won 1 match and D won 0 matches. So this is the ideal case where A is the complete total winner, B is the second guy, C is the third guy and D is a complete loser of a guy. So if this is what is given, you can see that how many matches are there. 3 plus 2 plus 1, there will be 6 matches. How do you figure out how many matches will be there? If A, B, C, D are all playing against each other, you can see there are 4 players. Each of them will play 3 matches each. Each of them will play 3 matches. 4 into 3 is 12. But my answer is coming out to be 6. Why? Because every match has 2 people. You'll divide it. And you'll say, okay, boss, there are 4 into 3 by 2, 6 matches that happen in this league tournament. Generally, if there are n teams, the number of matches will be NC2. Number of matches will be NC2. 4C2 comes out to be 6. Now let us first understand why did I make this matrix and what am I going to do with this matrix. So if A won all the 3 matches, let us just try to put these things into this table. So A, B, C and D are going to play against A, B, C and D, out of which we know for sure that A is not going to play against A, B won't play against B, C won't play against C and D won't play against D. D won't play against D. Now, if you look at what is the number of khali grids in this table, what is the number of khali grids in the table, empty grids in the table, you can find 1, 2, 3, 4, 5, 6 in the upper triangle and 1, 2, 3, 4, 5, 6 in the lower triangle. Actually, the numbers, the grids that are there in the lower triangle is a replica of whatever there is there in the upper triangle. For example, this match is nothing but A versus B. However, this match is also A versus B. Both of them are just transposes of each other. For example, this match is C versus B. This match is also C versus B. This match is also C versus B. So the first thing is you either use the lower triangle or use the upper triangle. Or if you want to use both, whatever you are putting in the lower triangle has to be translated into the upper triangle without fail. Okay, that is one understanding that I want you to have. Now let us consider for the moment I am only looking at what is happening in the lower triangle. Sirf lower triangle dekhte hai. Let us only look at lower triangle. Now I have given you that A has won all the 3 matches. If A has won all the 3 matches, just look at it. What are A's matches here? A's matches are versus B, C and D. If A has won all the 3 matches, I will probably write A over here, A over here and A over here because A has won all the 3 matches. B has won remaining 2 matches. Where are remaining 2 matches of B? This is one match of B which A won against him. The other 2 matches B will win against C and D only. So here and here I'll write B and here I'll write C because C won the remaining 1 match. So I have accounted for all the 6 matches. I have accounted for all the 6 matches. This is one way of representing data. What can be the other way of representing data over here? You read the table row wise. You read the table row wise. Meaning this is A's row, this is B's row, this is C's row, and this is D's row. You write with respect to these players what happened. Now A's row, in A's row, A versus B, this is the grid. A versus B, A must have 1. So you will write W. A must have 1 versus C, again W. A must have 1 versus D, again W. So when you're writing W, W and W over here, look at this. This is B's game against A. This is C's game against A. This is D's game against A. What happened to B against A? He lost. What happened to C against A? Lost. What happened to D against A? Lost. Now this is B's row. B must have 1 against C and D. We know that. So W, W. So again you'll write L and L, the transpose over here. Again C versus D. C has won it. C's row, in C's row, D's column, C's row, C has won it. So in D's row you'll write D versus C is lost. This is another way of representing the same data. This is another way of representing the same data. Overall, you can see there are 6 W's. That means 6 matches happen. Or you can see there are 6 L's, which also means 6 matches happen. But you'll see 12 grids over here. Why do you get those 12 grids? Because everyone will play 3 matches. 4 into 3. That is what 12 grids will be shown. However, you'll realize that, boss, there is a repetition of each of the match. There is a repetition of each of the match. So we are dividing it by 2 and making only 6 matches possible over there. So if that is understood, let us try and understand what happens in the points table. What happens in the points table? What is the total number of matches? We have already decided that the total number of matches is 6. We have already decoded that the total number of matches is 6. Now just look at what happens to A. A has played 3 matches, B has played 3 matches, C has played 3 matches, and D has also played 3 matches. You will find in the points table the total number of matches to be 12. But this is actually, if 12 is the count in the points table, again, 12 is the count in the points table, actually only 6 matches would have happened. Out of which A won 3, B won 2, C won 1, and D won 0. So how many did A lose? How many did A lose? 0. How many did B lose? 1. How many did C lose? 2. And how many did D lose? All 3. As a result, you will find 6 here and 6 here. How many matches won is the number of matches that happened. If there is no possibility of draw. Number of matches won is equal to number of matches that will have actually happened if there is no possibility of draw. Now, if I tell that for every match you win, you get 3 points. A will get 9 points. B will get 6 points. C will get 3 points and D will get 0 points. As a result, the total number of points in the table is 9 plus 6 plus 3, which is equal to 18. That you can see is 6 into 3 because every match carries 3 points. You win, you get 3 points. You lose, you get 0 points. Right? This is a basic table when there is no possibility of draw. Okay, the possibility of draw hoga, then there are other things that will happen that eventually you'll learn. But this is about the basic representation of data for games and tournaments in a round robin or a league tournament. League or round robin. Okay, basic representation, this is what it is. Now I come to the set. That was asked in CAT 2021 slot 1. This was a set of CAT 2021 slot 1. Now why did I say this set is a games and tournament set? Right? How are these related? Let's just check how this happens. One thing I want you to understand is, if A plays a match versus B, A's count in number of matches will be 1, B's count in number of matches will also be 1, but the total count of matches will also be 1. So whatever is reflected at A's end should also reflect at B's end. This is like dual entry that you do in the balance sheet. A win kar raha hai to B lose karega. That is something that you have to put across in the grid, in the matrix that you are using to represent data. So let's take a look at this set. So there are 7 friends, 7 people. A, B, C, D, E, F, and G are 7 people in a town. Any pair of them could be strangers, acquaintances, or friends. All relationships are mutual. All relationships are mutual. Mane kya? If A is a friend of B, then B is also a friend of A. That means if A is a friend of B, what you will get is, if A is a friend of B, A gets 1 friendship, B also gets 1 friendship, but the total number of friendships is only 1, it's not 2. That's only 1 relation that has happened. Similarly, if A is a stranger to B, then B is also a stranger to A. Similarly, A is an acquaintance to B will also be an acquaintance to A. So all relationships are mutual is given, right? Partial is information is given about the 4 friends, acquaintances, about the number of friends, acquaintances, and strangers of each of these people. So the following additional facts are also known. A, B, and C are mutually strangers. A, B और C का आपस में कोई संबंध नहीं. A, D, and F are E's friends. C and G are friends. Every friend of A is an acquaintance of B, and every acquaintance of B is a friend of A. So they are basically reverse of each other, right? It can be said कि boss अगर A wins a match against someone, B loses against him. B wins a match against someone, A loses against him. They are interrelated. Every friend of B is an acquaintance of A, and every acquaintance of A is also a friend of B. So whatever is a friend of A, A's friend is B's acquaintance. Similarly, B's friend is A's acquaintance, and vice versa. It is given like that. These are the points that are given. And then there is a beautiful little table given in which there are some number of friends given, some number of acquaintances given, and number of strangers that are given, but the table is incomplete. This is missing data. Let us take a look at what are the questions. The questions are definite fixed answer questions. Who are Gautam's acquaintances? Pakka chahiye isko. Which of these pairs are the same type of relationship? Pakka chahiye. Who is an acquaintance of A? Pakka chahiye answer. Who is an acquaintance of C? Again, pakka chahiye answer. So if these are the 4 questions for which there is a pakka answer possible, it is throwing an indication towards me that boss, you form the table. You form the table or the grid correctly, you'll get the answer. You'll get the answers to all of them. So you can very well spend about 10 minutes to 12 minutes also for the table, because once you get the table, there is no thinking about it. The 4 questions can be answered in less than 2 minutes once you get the table. That is the kind of idea that the questions are giving us. So now let us take a look at what can be done. So what I have created is, see, what this is a points table. Number of friends, number of acquaintances, and number of strangers is like number of wins, number of losses, and number of draws. And A, B, C, D, E, F, G have a mutual relationship with each other. So what we have done is, boss, A won't have a relation with A, B won't have a relation with B. ये सब cross कर दिया. ये सब cross कर दिया. Now how many grids do I have? I have 7 into 6, 42 grids to be filled. 42 grids to be filled using the data that is given. So I hope all of you understood what the setup is like. Now let us directly try and put the values into the table, into the grid. Let us try and put the relations into the grid. Now I am also going to read this row wise. Okay. For friend, I'll write friend. For acquaintance, I'll write A. And for stranger, I'll write S. These are the 3 things that I'll put on the table in the entire grid. Okay. First of all, let us see what all things can be definitely determined. Look at the points table. You have 4 strangers, 1 acquaintance, and barring A, there are 6 people. If 4 of them are strangers, 1 of them is an acquaintance, the number of friends that A should have is 1. We also know every friend of A is an acquaintance of B, and every acquaintance of B is a friend of A. Similarly, every friend of B is an acquaintance of A, and every acquaintance of A is a friend of B. That means number of acquaintances of A is number of friends of B. Number of friends of A is number of acquaintances of B. So 1 is 1 and 1. So number of strangers that B will have is also 4. Number of strangers that B will have is also 4. Number of friends that Gautam will have, G. Number of acquaintances he has is 3. 3 plus 2, 5. There's only 1 relationship left. So Gautam will have only 1 friend also. Gautam will also have exactly 1 friend. These are the things that we can directly determine from the table before starting filling the grid. Now look at this. A, B, and C are mutual strangers. So for A, B and C are strangers. For B, A and C are strangers. For C, A and B are strangers. Just look at it. Whatever I have put in the lower triangle is reflecting in the upper triangle also. Right? B versus A is strangers. A versus B is also a stranger. A, D, and F are Ezel's friends. So A is a friend of E. A is a friend of E, D is a friend of E, D is a friend of E, and F is also a friend of E. F is a friend of E. So E has 3 friends. Positively, E has at least 3 friends. So 3 to hai E. Let us write 3 there. I'm not sure if that is the total final number. Similarly, in E's row, I'll mark A, D, and F to be friends. E versus A is a friend. E versus D is a friend, and E versus F is also a friend. So let us just check whatever is there in the lower triangle, the transpose is present in the upper triangle. C and G are friends. C and G are friends. So Chandra and Gautam are friends is given. So C has a friend who is G, and G has a friend who is C. So these are the points that we could fill directly using the additional points that are there. There should be one odd extra inference. There has to be one odd extra inference that you should be able to pull out of this. That you should be able to pull out of this so that you get to your answers. What could be that extra inference? What could be that extra inference? See, G has only one friend. G has only one friend. Okay. G over here has only one friend. E over here has 3 friends. That is something that we have already put into the table. Now we don't know how many friends does F have, how many strangers does F have, or how F also has exactly one friend is given. Also has exactly one friend. So F cannot be a friend to A. F cannot be a friend to A. A has only one friend and we have covered that. F cannot be a friend to A, right? F cannot be a friend to B also. F cannot be a friend to B also because F has exactly one friend. F cannot be a friend to B also. So if F is not a friend of B, F cannot be an acquaintance of A. And if F is not an acquaintance of A and F is not also a friend of A, can I say F is a stranger to A? F is a stranger to A, so A is a stranger to F. A is a stranger to F. Similarly, you can look at A has a friendship with G. Is that possible? Can A have a friendship with G? G has only one friend, and we have marked that friend to be C. So A cannot have a friendship with G. A cannot have a friendship with G. Can G be an acquaintance of A? If G is an acquaintance of A, he'll automatically become a friend of B. If G is an acquaintance of A, he'll automatically become a friend of B, which is not possible because G has only one friendship, that is with C. So G also is a stranger to A. If G is a stranger to A is a stranger to G. Now look at A's row. We need one friend, one acquaintance, and 4 strangers. We have one friend and 4 strangers already, so D must be an acquaintance of A. D must be an acquaintance of A. And if D is an acquaintance of B, what is D to B? What is D to B? D must be a friend of B. D must be a friend of B. D must be a friend of B. Now again, B has only one friend. B has only one friend, one acquaintance. D has only one friend, one acquaintance, and 4 strangers. Now look at this. E is a friend of A. If E is a friend of A, E is automatically an acquaintance to B. E is automatically an acquaintance to B. So for B, we need one friend, one acquaintance, and 4 strangers. One friend, one acquaintance, and 4 strangers. We already have one friend and one acquaintance. In B's column, we need 2 more strangers. We need 2 more strangers. So A is done, B is done. Done and dusted. Totally, A and B are completely done. A and B are completely done. Now what else are we left with? What else are we left with? Gautam needs 3 acquaintances. How many blanks are there in G's row? Only 3. So all 3 of them will have to be acquaintances A, and A. So this is also A, and A. And G has a friendship with C. G has a friendship with C. Has to be put over here. G has a friendship with C. Has to be put over here. C doesn't have a friendship with F. C has a friendship with G. Okay, so these are the things that we already have. Now look at what has to happen for D. D needs 2 strangers. D needs 2 strangers. There are only 2 blocks left in D's column, so these 2 are definitely strangers. These two are definitely strangers. So S and S for D. Done. So D has two strangers. C already has one acquaintance. C needs to have one acquaintance. C needs to have number of strangers of C is not given. So number of strangers of C could be 3 or 4 or 5. 3 or 4. We don't know that yet. Now let us look at E. E needs to have one stranger, and in each row there is only one column, one slot that is empty. So E is a stranger to C. If E is a stranger to C, C is a stranger to E. That being put, what else is required? F needs C needs one acquaintance. C needs one acquaintance. So if C needs one acquaintance, C gets one acquaintance with F. That means F is an acquaintance to C, and we have established the relationship between each and every one out of these 7 people. Using whatever little data is given, we can establish that relationship very beautifully. Now let us take a look at what the questions are. Who are Gautam's acquaintances? G's acquaintances. All you need to do is G's acquaintances. These 3 people, D, E, and F. D, E, and F are G's acquaintances. Which of these pairs share the same type of relationship? C and E, D and G. C and E and D and G. C and E are strangers. D and G are acquaintances. No, option 1 is not the same type of relationship. B and C, D and E. B and C, B and C are strangers. B and C are strangers. D and E, D and E are friends. Not the same type of relationship. Option 2 is not correct. B and E, F and G. F and G are acquaintances. F and G are acquaintances. B and E, B and E are also acquaintances. B and E are acquaintances, and F and G are acquaintances. So this pair of people share the exact same type of relationship. So option 3 should be the correct answer to this. Who is an acquaintance of Amuda? There is only one acquaintance that Amuda has. Let us find out who that is. It is D. It is D. So Dinesh is an acquaintance of Amuda. Who is an acquaintance of Chandran? Who is an acquaintance of C? There is also exactly one acquaintance to C, that is F. Funny is the acquaintance to C. So that's all. That's about the entire set, guys. Once you understand what is data, how data has to be represented in terms of games and tournaments kind of a set, now you may very well argue with me कि ये तो friends acquaintances बोल रहा है, games and tournaments नहीं है. To my mind, it is games and tournaments only, because whatever I am doing to use to represent data in games and tournaments, the exact same thing we have used over here. So this is a pretty much a set of games and tournaments. Instead of wins, losses, and draws, what is given is number of friends, number of acquaintances, and number of strangers, and we had to use the same logic of whatever is there in the lower triangle has to be there in the upper triangle as well. So that was the set, guys.